Hey everyone. So today we're shifting gears. We're shifting out of the C world into the Java programming world. Well, why are we doing this? Well, there's a couple big reasons. One of the most or primary reasons is that next semester, as you move beyond programming for engineers, you're going to go into your next class, which is the data structures class. That class is going to be 100% in Java. So part of what we're doing here is at the latter part of the semester, is we're trying to ease your transition from one language into another so that you don't get shocked with it right in the beginning of the data structures course when you're expected to know some of the fundamentals. Now here's the good news. You're going to find that a lot of the fundamentals, a very, very large amount of things that we've talked about in C, are extremely relevant, very similar, and sometimes flat out identical to what you're seeing in Java. As you learn more programming languages, you're going to find that there is the thought process as well as things like the syntax, the grammar of the language, can oftentimes be exceptionally similar. And we're going to see some of that in this first video here today. Okay, so we're going to jump in and talk about Java. And as right in this first video, we're going to see that there's not necessarily a huge difference. I'm going to point out some of the kind of big fundamental things that are that you want to keep your eye on in terms of some of the basics. And one thing that you're going to find is that as you get more experience programming, you're going to actually be able to jump in and out of different languages without a ton of difficulty as you get more experience, as you're a little bit more mature in terms of how your knowledge base. Okay. Now, different languages exist for a reason. If there was one perfect programming language, everybody would use that. And we wouldn't have a need to go and be talking about why there's different languages and why we're going to use one versus the other. There's trade-offs, right? So there's a very large number of different programming languages, and one of the big reasons for that is there's trade-offs associated with each one. Now, I showed this slide a while back. You might recall, this might look familiar to you, and I think it's worth just pointing out as we're shifting from one language to another, some of the differences between, say, C and a language like Java, okay? Some of these differences are not going to make sense now. They're going to make more sense when we talk about something called object-oriented programming later on. It's one of the main fundamental reasons we want to talk about Java. Something that does. There's some things that don't exist in C that do in Java. We'll get to that. Okay, so C is oftentimes, I like this analogy where if you're trying to get something done, right? And C is an example, like say you're trying to move some stuff around. C is like the example of you're moving things around in a backpack and you're walking around. Well, you might not be able to carry a lot, but you're walking, you can go any sort of different direction you want. You have a lot of control of your movement. You can move to left, right, forward, back very easily, right? So you have an awful lot of control of what you're doing, but it's very hard to get a ton done and to be very productive in terms of like the bigger picture things, right? Other languages are like trains, right? Where you can move a lot of stuff and you can do some things really easily, but you don't have that control. You're stuck on the tracks, okay? Java's more along the lines of like the railroad example, okay? So, matter of fact, there's an awful lot of things that when we see it in Java are going to look way easier than we've seen in C, okay? But it doesn't mean that one language is better than the other. It really depends on what problem you are trying to solve, okay? Certain problems, Java makes a lot of sense. Certain problems, C makes a lot of sense. And there's a whole host of other problems that neither one makes sense. Okay, it depends on the problem. Okay, let's look at a simple hello world example here. Okay, hello world is like this really almost like famous examples when you're trying to do anything, whether it's programming, particularly programming for the first time, right? It's meant to be like the simplest program you can possibly write. Okay, it's the program that all it does is display hello world to the screen. Now we've seen the example below in C. We've seen this using printf, just printing this string, hello world, with the new line here. We've seen that, okay? In Java it looks really similar, but I want to point out a few different nuanced differences, okay? First, let's just take a look at this one line here, the line that actually prints hello world. Some things are syntactically extraordinarily similar, and this cuts across a very large number of programming languages. And for one is that strings end up being designated with the quote-unquote double quotes, right? Double quotes indicate a string. Hello world's a string. We're printing that to the screen. Okay. Instead of printf, we're going to use something called system.out.println. Okay, the ln stands for line, literally print a line. Okay, now notice C, we have to use this end of line character, right, which can be a little bit annoying, having this end of line character here, always a /n. In Java, the ln indicates that we want to have a new line after this string. Okay, if we didn't want a new line, we could just say .print here. Okay, that will also work, just does not do the end of line at the end. Okay. Now, a couple things look a little bit differently, but let's focus on what's the same first. We have main, that's the starting point of our program. Might look a little bit different. We've got this public static void, right, instead of just void. Okay, right now, just put that in there, right? I'll talk more about public later on. You've seen static before, and what that's basically indicating is that there's one copy of this function, which is, don't worry too much about, okay? And so that looks very, very similar, right? And the same basic idea as C, right? Now we have this other thing here, this public class, okay, and some sort of name. You can give this name whatever you want, okay, within just some basic rules. And this wraps the main function, okay, it wraps it. And this is something that we're going to learn more about in subsequent videos. I don't want to get too bogged down in it now because it could be a bit of a distraction. Okay, but in Java, let me point out a couple things about Java that are quite important. Okay, for one, every single file, every file is going to have this type, something at least extremely similar to this. Okay, it says public class in the name of the class. Okay, and there's going to be one of these. We'll learn more about what classes are later on, but just for now, just keep that in mind. These classes, okay, there's one per file. Okay, and we want that. Ignore the package for a second, but the name of the class must match the name of the file. Okay, so here I called it my class name. That must match over here. The name of the file is also my class name.java. Okay. Now we'll talk more about what that means later on. Okay, but Java's all based around this idea of stuff called classes. Okay, let's not get bogged down in it. Let's learn some of the fundamentals first, and then we're going to introduce it. Okay. The other thing to show here is in C we're used to having these include statements at the top. Okay, include statements at the top. Okay, Java, it's a very similar idea, and there's different types of ways in which we can include code into our file, the file that we're into our class. Okay, here we're doing something where we're including a package. Okay, notice I named it edu.albany.sandboxjava. Okay, the package is, notice that this class that we defined, this file that we defined, is in that package. Okay, what that does is if I add multiple other files in here, okay, underneath that same little package here, where you can almost, it really acts like a directory. Okay, if I have multiple files, multiple Java classes, multiple Java files there, okay, that's fine. And what that does is you're allowed to do that, and we have a nice easy way of allowing this class here to have access to be able to call stuff in those different files. Okay, we will see more about that later, but I don't want to show you anything in the code that you're looking at, this simple example, without at least kind of pointing out that this is needed, because you're not going to be able to run it without that. Okay, so what do you need to know starting off? Just bare bones, basic stuff. What do you need to know? Okay, for one, right, remember, everything in Java is a class. Okay, so we're going to have this public class and give it some sort of name. Okay, typical convention is to keep it with an uppercase first letter. Right, we're going to wrap that around whatever's in that file. Okay, the name of the class must match the file name. Okay, and we have this package here, and we want this package to match the name of the package here. Okay, that's the bare bones starting point, and that allows us to get deeper into some of the fundamentals as we move along. Okay. Now let's look at another fundamental programming construct, which is basically data types, or in this case I'm going to refer to as primitive data types. And if you recall, when we saw C, when we were introduced to the C programming language, we talked about this idea of what is a primitive data type. And just to kind of refresh your memory, right, a primitive data type is a data type that is built into the language. Okay, it's built in, it's kind of a fundamental construct that you have access to use, right? So Java has 8 that are built in, they're listed here, and they should look really, really familiar to you, okay? You have these things like your double, your char, your int, your long, that kind of stuff. We've seen this all before, right? Couple nuanced differences. We've got Boolean is built in. We don't need a library for it. Okay, it's true or false, right? We've got things like byte, you know. So there's some other things we have access to use. I don't want to get bogged down too much into it, but the key thing is they're extremely similar. Okay, really similar to what we saw in C. Okay. Now there's a couple things that are actually a lot easier in Java. Okay. So for one, even like Booleans are much easier. They're already built in. We don't even have to include the library for it. Okay. Most stuff works just the same way we've seen in C. Okay, we see if we got like a character here, we got single quotes, right? Single quotes designates one single character. And then if we've got a string, it's double quotes. Okay. Now, strings are actually a lot easier in Java compared to C. And I don't need the string class, right? There's a lot of built-in functionality related to strings. So here I can actually just, instead of declaring an array of characters to designate a string, in Java I can just use this construct, right, to say string with a capital S, right? That in of itself is a data type that is built into the language. It's in one of the common libraries, right, that's kind of built into what you tend to have access to. And here I could just say string and designate it that way, and we're going to see that strings are way easier to deal with in Java compared to C. Okay, so let's look at some examples, right? Now this is an example here. This is done in C. Okay, so this is just to kind of be familiar to you, stuff that you've seen in the past. And well, what do we have going here? All right, I've declared 3 different data types. I've got an array of characters, aka a string, word1. Okay, then I have a single, well actually, and also another string with space, but it just stores literally one space. And then I have another string, world. Okay, and what this does is we want to think about what these are in terms of how they're stored. Okay, and like I said, remember this is in C, and I'm doing this first to illustrate the difference in terms of how C manages this type of data compared to Java. Okay, so if we look at this first one here, right, what we're doing, right, with word1 is we've got 32 characters that we could store, and we're storing this hello like this with the null terminator, and then everything else is blank. Okay, and then here with the space one, okay, I'm storing exactly 2. I've got a blank space character followed by the null terminator. Okay, and then the last string here, okay, we're going world, okay, with the null terminator, and then there's a whole bunch of extra space that we're not using. Okay, now what does this do, right? We might not have seen in the past these ideas of using this string concat function, but let me just show you what's going on here. That function takes this word1, okay, so this is word1 here, okay, and that one, as we saw before, it's initialized to the word hello with the null terminator and then a bunch of blank space, okay. And what happens is, when we hit this line here with the string concat line, what's going to happen is we are going to put the space, okay, and we're going to have that, or we have a blank space. That's going to happen with this line here, okay, and then the next line is going to concatenate on the next one, okay, so it's going to do this. Okay, such that when we print at the very bottom here, when we print word1, it's no longer a single word. It literally prints this entire thing, hello world, right, with the space in the world, right? This has all 3 pieces. Okay, that's kind of ugly, right? You think about like the logic behind that's pretty simple. You're concatenating 3 strings together, but it's actually kind of hard to do. C makes it very mechanical in terms of like you're using this string concat library, right? You got so you're having that function call in there, not library, string concat function in the string library. And we've got weird things, right? You've got to remember the format specifier here, right? So C has got all that like really bare bones, nitty gritty stuff that you need. Well, let's see how to do it in Java, right? And it's conceptually way easier, right? So we've got here, we got string word1, right? And actually, I could even make space a character because I don't need space for the null terminator. String word 2. And to concatenate them, I could literally just use this. I could just use here the add operator, okay? Because the plus sign, the plus or the add operator knows that when we have a string plus a character or a string plus a string, that by default is a concatenation operation. Okay, so that knows to concatenate, just stick them together. So this will also print hello space world. Okay, now I think if you look at that, that's way, way easier conceptually to deal with, right? So strings are your friend in Java. Boolean's really simple. This is like a very, very basic example, but I think it's worth illustrating it, right? We just have a Boolean here. Boolean is valid equals true, okay? And if I want to check whether that's true or false, I don't necessarily need to do this, although I could say, hey, is it equal true? I actually don't need to do that, okay? It's the same thing whether I include that or not. Okay, so of course this is going to print out Boolean is true. Okay, if I changed it to false, right? If I changed it to false, it would print out Boolean is false. This is a really basic example, but I'm just showing it, kind of giving you a sense of some things that are a little bit different, and matter of fact are easier in Java. Okay, reading things from the user, right? Very basic thing. We need to do that a lot. Okay, we've seen this repeatedly, right? We've been using scanf to do that. So here's an example of reading in a string from the user. We're declaring space for it here, right? We have scanf, we've got the format specifier, and we have where it's going, right? The address of where it's going. And then I'm just here, it's printing it out. So here, if I typed in hello, it would say you entered hello, right? Very basic stuff. Now, here's the great thing, right? In Java, there are no such thing as the format specifier. Okay, which I'm sure people are happy about because they're a pain, right? They're a pain. Now again, C is not doing that or forcing you to do that to be mean. It's doing it because it's giving you an awful large amount of control. And as computer engineers, we often want that element of control. We're doing things really close to the hardware, right? We're dealing with very specific hardware level resources and we want that level of control, okay? But there's all sorts of times that you do not want that level of control. You'd rather just make things easier. Okay, and that's why these languages exist. All right, so let's see how we do it in Java. It's a lot easier, right? We're going to see this line here called scanner, right? And for now, just you're going to include this, right? This allows you to use. I'm declaring what we're going to call an object, but you think of it now as a variable of type scanner. And what that is that allows me to read from the standard input that is basically your keyboard, okay? So that's saying the system.in, that's like your standard input into the program, right, your keyboard. And it's saying, okay, setting this up, this thing called scanner, to be able to scan for input that the user's entering. And if I want to enter a string, I'm just going to say in.nextLine. So basically you could type in an entire line, right, hit enter, and that string that the user typed is going to get, this S is going to get placed in there. Okay. Now notice, it's way easier than C. I do not need to say how big the string is going to be, what's the max size, right? I don't need to do that, right? That's going to be handled for me. Okay, much simpler. Okay, so this will print if I typed in hello, it'll say you entered string hello. Okay, notice we can have double quotes and concatenate it with the plus sign. Okay. Right, you can't do that in C, right? That doesn't work that way. A lot of things are simpler, right? A lot of things are identical or extraordinarily similar. Right, so that's how we would do it in Java. Okay, remember you need this scanner. Okay, and we do notice up here, in addition to the package that we've added before, I've got this thing called import java.util.scanner. Okay, this is the library I need. All right, so in C, we're doing include. Okay, this here is like our inversion of include. Okay, same idea. We're using something called import instead, but it's the same fundamental concept. Okay, syntax, right? The grammar of the language, a little bit different, but it's the same basic idea. Okay. All right, So let's just do a little bit more with some of the differences, because I showed you how to read in a string here in Java. Let's look at how we would do other data types. Okay, so I'm jumping back and forth between C and Java because that's what you're familiar with, right? You're coming into this being familiar with C, right? So I want to show you oftentimes examples in C and be like, okay, this is how we've done it before, and then we're going to look at how to do it differently. Okay, and these things tend to be fairly basic once you spend some time getting used to them, right? Because you know you have a little reference sheet, something that kind of clarifies some of the differences that you can look at to kind of remind yourself, right? There's nothing wrong with that. It tends to be very helpful little hints or reminders about some of the nuanced differences. Okay. Now, so in C, if we were going to read in, say, a string followed by an integer followed by a float, we would do it this way, right? We declare the string or the character array, right? We use the format specifier. We declare the integer, we use the format specifier for that. We declare a float, we enter the format specifier for that. And we got to remember a lot of ugly details such as the ampersands and stuff, right? Strings or arrays are already pointers, so we don't need the ampersand because they're already storing an address to a memory location, right? But we've got these other ones like int and float. We need to include ampersands because we have to say, hey, store the value in that address, okay? So that'll prompt the user to enter a string, print it out, enter an integer, print it out, enter a float, and then print it out. Okay, let's look at how we do the same thing in Java. Okay, we already saw the string before. We've got the same scanner utility. Okay, we're going to say in.nextLine, right, to get a string. And if we wanted an int as the next thing, we're going to say in.nextInt. Okay, to read it in as an integer, float, in.nextFloat. Okay, that does the same thing as that prior example. Okay. Now, if we look at the documentation, okay, if we look at the documentation of the scanner, right, in the scanner library, we're going to see it's got a whole bunch of stuff such as how we read in a Boolean or a double or a long and so forth. And let me just show you something really quick here in NetBeans, which is a super helpful thing to have, right, is let me just go ahead and declare a scanner. Okay, and notice if I did something like in, and I'm going to press dot here, that when I do that, it prompts me by default with all this super helpful stuff. Okay, so this is like basically dot completion. It tells me all of these different things that exist within that scanner. Okay, and it's actually something called the scanner object, right? Anything that I can use, and I will explain much deeper, but we've got things like next float, next double, next line, and then also down at the bottom, right, we could see all these things like some super helpful documentation that comes up, describes what's returned, what the function does, right? I'm gonna stop in just a moment, but what I want to point out is there's tons of functionality in these different libraries things are built in. There is no way you are going to memorize all of the different things that are available. Okay, so being able to read documentation, be able to understand what the documentation means, right, and be able to then use things that you're able to find as being appropriate uses is an extraordinarily useful skill, right? And being able to say, okay, I've got this scanner class here, a scanner object, which we'll learn more about what classes and objects are later on, and be able to say, okay, I can go ahead and use that, and I got the fire alarm going off, but I'm going to wrap up this video because I am basically done anyway, right? That's what we know. That's how we know that dinner's done around here is the fire alarm goes off. So it's time for me to eat. My fiance's cracking up about that because I think she heard me say that in the other room. But we're having a crash course in Java here. All right, you're going to get used to it. It's going to help you a lot as you go into next semester, right? And so let me stop. And we'll follow up in future videos in which we learn some more of the fundamentals with Java. All right, so stay safe and healthy, everyone. All right, take care.